Thanks for sticking by. Last day of the last day of the conference, last session, post-election, hangover, if you want to call it that. So Damon touched on a couple of sort of key points around NoSQL analytics, why it's needed, and so on. So I'll keep the slide portion of it brief, and we'll get into a sort of a real-world demo. So the demo itself is around connecting to Couchbase Live. It's got a 40 million data set around New York City cab rides, and sort of do some analysis on that itself. On the value prop and the what we do in terms of Cloud9 Chart itself, you got the data stack itself has been changing for the past couple of years, right? So you get your traditional relational data sources, which is now supplanted in some ways by these NoSQL databases that have basically gained mainstream adoption. And more what we see is this polyglot persistence architecture, where you have multiple data sources inside the enterprise, where you might have Couchbase for semi-structured data, Elasticsearch, relational databases, REST APIs, and so on and so forth. So the thing to that is when you try and match the traditional BI tools on top of these NoSQL databases, it doesn't work that well, right? It's a little bit like putting lipstick on a pig. So there's a whole process. Typically, what you do is you grab the data you want, put that into a relational store, and then put your traditional BI tools on top. And as Damon mentioned earlier, you change one attribute or add a new field, it's a whole cycle back in 8-week cycle back on again. So what we provide is this native analytics layer on top of all major NoSQL databases. So have support for 30 data sources, including all well-known data sources. And there's a data layer underneath that helps you to do more advanced things like multi-data source joins. And then the actual integration itself is pushed down into the database based on the native integration itself. So with Couchbase, for example, it'd be you type in NQL queries, or there's a NQL query generator, and it gets pushed down into the database. Right? And then on top of that, you can take the results, merge that up, or join that up with REST APIs or JSON files, or your traditional SQL-based data sources. So in terms of the demo itself, the data itself is flat, but we deal with nested data sets too. So it's got first-class JSON support, and it's a data set that was put together basically by the New York City taxi service, and this is specifically around the green cabs service that was launched a couple of years ago within New York City. With that, I'll jump right into a demo here. Give me 1 second. So switch up. So the Couchbase database itself, Prasad and team helped us put that together, and then there's 40 million records inside it, as I mentioned earlier, and we'll run some queries on that. So there's first I will put some analysis on pickup locations as well as drop-off locations, and then run through a scenario of if you're a taxi cab vendor or a driver, how do you best deploy your assets, right? So we'll walk through that. So a couple of key things on this plumbing side of things. One is you can generate the NQL queries directly. So so you can plug in, you write up your complicated NQL queries here, or you can pick the list of the list of buckets showing up. And let's say you got green taxi cab data, and then what we do then is use the info command for 451. To find out what's inside the database or inside that bucket. Then once you select the fields, the query itself gets generated, or you can plug those in directly. And the couple of key things to note here is that is then pushed down into Couchbase directly, and then we get the results and put that together. So in this case, we're looking at pickup locations. So we'll pick up a couple of these fields. Hit preview. Now this is going to run against the cluster and get us some data back, along with some visualizations you can modify right off the bat. We won't modify the visualizations right here. We'll add that into a dashboard and do some visualizations there. Okay. Also, while we're in the topic, we're just going to make one more change, to get the drop-off locations too, so we can compare them side by side. Just make sure I got the query right. So now you've got pickup locations and drop-off locations, okay? We'll put that into a dashboard and then do some, run through some visual analysis on that. So dashboard is basically a collection of visualizations you can publish out. You can embed them, a single sign-on built in if you want to share that against a specific set of users. So this, the pickups and drop-offs right now, it's not particularly useful. I'm just going to go in and do a couple of small setting changes here just to zoom in. So do the same for so a couple of things to see here, right? So in the on the New York City green cab data, the section down south, they're not allowed to do pickups. So that's why on the left hand the widget there is an empty section here essentially. So that is a yellow cab specific, pickup region. So a couple of things that comes out right away. If you're a owner of a taxi cab, then how do you plan your day in terms of where do you pick up folks from, right? And if I have to go in and drop someone off to Chelsea, that is not a very cost-effective day for me because it's going to take me a number of minutes to go in and get back. So let's continue on that analysis a little bit. So let's take a couple of those that I've created the nickel queries for earlier. Let's take the rides from and to. So if you're in Harlem and if you're going, if your day starts in Harlem, most of your rides also go to Harlem as well, right? So, but if you're going from, if you have, say, dropping someone off at Hamilton Heights, there is a 60% chance that they're not coming back. You're not going to get a ride back to basically Harlem. And taking that one step further, if you take the duration of the trip, say if you're going to somewhere like Chelsea versus a Brooklyn area, there's this, you can slice and dice the data in a number of ways. So, for example, if it's Chelsea, you're basically on Wednesday during peak time, it's a half an hour trip, which means you got to get your cab down to Chelsea and then head back, right? And the fare associated to that for Wednesday is set up a drill down here in this case to go into Wednesday for pickup from Chelsea. So at $28. So for an hour, it's not really worth that the driver's time. Whereas if you change that up to say Fort Greene, which is in Brooklyn, it's an hour's worth of journey for $40-50 plus you get there's a lot more probability that you're going to get a ride back from here instead of going back from Manhattan area. I'll do two more things and I'll wrap up the demo here. So the question I asked earlier about how do I best deploy my asset in terms of the taxi cab. Various areas you can basically, we've done some analysis on where you get the most bang for your buck, essentially. So if you're Thursday at 10 o'clock, say it's Jamaica is your best bet where you can land a average fare of $40, versus if it's at 8 in the morning, it's Sheepshead Bay, you know. And one last thing I'd like to show before start taking questions is a trend analysis. So this is the trend after the service was launched, right? So monthly trends since 2013. So based on this, you know, you have the initial ramp up, and then kind of things slow down here. Now, there's a drag and drop analytics mode as well. So you can set analyze on that, and if you want to do some predictive analytics on this, you can basically create that right off this here without having to go back into the database tier itself. So in this case, we'll try to predict the next 6 months based on the historical data, where we'll pass it through a number of predictive algorithms to pick the best one, back test it, and say, hey, this is what we expect that number to be. Start from 2014 data, just because it started, you know, back in 2013. And the section on the right with the yellow stuff is the predicted numbers that you see for the cab rates. So just to summarize, a couple of things went through. The value proposition of native NoSQL analytics, not having to go through that ODBC drivers or trying to shoehorn your traditional BI tools on top of NoSQL on top of NoSQL databases, as well as being able to connect to an underlying NoSQL database, pull the data using NQL queries under the hood, and being able to visualize and analyze that data and do some predictive stuff on. So in terms of, you know, we do, if there's interest in checking out how that Couchbase the integration works, there's a landing page on the cloud9charts.com Couchbase, which connects up to one of our Couchbase instances, so you can play around and, you know, with the BS sample data and the travel sample data. With that's it from my end. Questions?
Similar to the question from earlier.
Yeah.
Can you do cross data source joins?
Yes. Yeah. So the way it works is, you know, you execute, say, query against Couchbase, you get some data back, right? And then let's say you join against a REST API, and you get some data back. You can manipulate that data as well as, you know, change the names of the fields or add some calculations along the way. So there's a transformation layer optional on top of the results if you want to, and then get the results and track that if you like. And that whole thing could be, you know, live into the database, where you're executing that live against Couchbase and that REST API, or you can do this synchronously on a schedule, and we'll track and incrementally update that, you know, data set itself.
That's a separate question. How do you merge the data set? One, they have two different data sources, right? You push all the way to the end of the server. How they join? And the data at server level.
At the server level, so basically we have a pretty sophisticated processing layer that can basically run it as, you know, we have this concept of an agent, right? This agent can be right inside your cluster, close to a database or databases, where it can basically execute one query and then execute the other one and then do the join. And that happens in memory plus disk if it's spills over. And then the results of it is what gets displayed real time or cached. It can, yeah. I mean, you can either run it directly on the UI where it's direct, or there's a concept of an agent that runs, you know, it's distributed essentially. So you know, since there are two questions around that, essentially the way I'll show you join example. I don't have an example specifically with Couchbase, but I'll show you what it looks like. So let's say I pick one of these. So now it's got sent by customer on data source A, right? And then if I join that up with, say, MySQL database, and where the customer information itself is in that table, and then you can specify a key across them. If you don't, it will just basically do a straight blend, right? So now you should see sent and customer along with the customer details joined up. So on the right-hand side is all the join from the secondary data sources. And you can join a number of data sources.
One question I should have asked both of you guys. If you want to try this out, what do you do?
So with us, you just go to Cloud9 Charts, and you can sign up, and there's basically, it's free to get started essentially, and yeah, and I think with SlamData, if I'm not speaking out of turn, you go to their site and you can download the software, and as well as a GitHub, right?
Yeah, GitHub is probably the best since it's the most recent. Yeah, there's instructions.
Yeah, and so there is, as I mentioned, there's a landing page with that Couchbase instance. So if it's and it's pre-connected to one of our Couchbase instances, and that has a beer sample and the travel sample data, so you can go in and plug in your nickel queries and see right away. You don't even have to sign up. Done. Well, thank you very much, guys. Yeah, appreciate it.